Hello there, once again, welcome back to our series of mathematics. My name is still Hamza Luwama, and I am here today to proceed with integration. And today we have type 3, which is going to be called change of variable. Some of the methods we have seen in type 1 maybe and type 2. Some numbers we could as well use other methods. Among those methods we have what we call the change of variable. So in change of variable, we expect to change the variable. If your husband, or if your mother, or if your mom's husband has been substituted, and maybe they have had a divorce, and mommy brings in a new man into the house, then it means mommy has changed the variable. She has changed the variable who is the husband. If the husband does the same, changes the wife, then the wife which was initially the wife in the house now no longer becomes the wife. The same applies to substitutions in games. When someone has been removed, they have changed the variable. That's why when people come on pitches, you'll see the type of play may change because the variable has changed. So when you change the variable, for example, you have to let. For example, what do you let? You let what you can easily differentiate into designing the outside term. For example, I let x squared plus 4 be u. In this sense, I get the derivative of u, which is going to be equal to, with respect to x, it's going to be 2x plus 0, and therefore du dx will become 2x. It means du is going to be 2x dx. And according to our question, we have an x and a dx. Therefore, if I make x dx the subject, I'll have a half of du. It is from here that now you change the variable and substitute. Where you have x, or where you have x squared plus 4, you put u. Where you have x dx, you put a half du. So I will have x dx is a half du. X squared plus 4 power 5, I will now have u power 5. So I change the variable to u power 5 times a half of du. So it is now easily integrable if I say it's a half integral of u power 5 du. And from this result, you will see that the integral of that is going to be 1 over 2 times the integral of u power 5. You increase the power by 1, which will give us u power 6 out of 6 plus a constant. Therefore, this will be 1 out of 12 of u power 6 plus a constant. But the question was not given in terms of u. The question was given in terms of x. So you have to bring back what was given in the question and resubstitute it back. You rechange the variable again by bringing back what was given. So what will be given is going to be integral of x into x squared plus 4 to the power 5 dx is going to be 1 out of 12 of u. Our u actually says x squared plus 4 to the power 6 plus a constant. And that will be your solution after integrating using this technique of what we are calling the change of variable. So that's example 1 for you in this category of change of variable. I can bring about example 2. Example 2, we can have the integral of sine to the square of 4x cos of 4x dx. In this sense, we can have the following. You can let the one with the highest power be the one you're going to change the variable. So I let u be equal to sine of 4x. Then the derivative technique of trig functions is PTA, power if there is a power, trig function if there is a trig function, then the angle if there is an angle in terms of the variable x. So du dx will be, there is no power, so forget the power. There is a trig function, derivative of sine, you get what? Cos of the same angle. Then differentiate the angle, the derivative of 4x, you get 4. So it means du is going to be equal to 4 cos 4x of dx. So according to this cos of 4x dx, it is right here in the question. So the whole of this in the question is going to be represented by du divided by 4. So it's from here that you will say the following. Now the integral sine squared of 4x, sine of 4x we saw is u squared times du divided by 4. It is from that note that I can comfortably say this is going to be a quarter integral of u squared du. And my result will be 1 over 4 times 1 over 3 of u to the cube plus a constant of integration. These ones are for indefinite integrals so far. We are going to see more which have limits, which will be definite integrals. So therefore, this will give us 1 out of 12 u to the cube plus a constant. Now remember I said you have to bring back what was given in the question. The question was reading sine of 4x, which we substituted in as u. So I bring it back and I will say the integral of sine to the square of 4x cos of 4x dx is going to be equal to the integral, which is 1 out of 12 sine to the cube of 4x plus a constant, and that is going to be your solution for this problem. So with this, so far, these first two examples, we are looking at what we are calling the method of change of variable, which is type 3 of integration. So let's look at example 3, but this time round, we are going to have example 3 when it has got what we call limits. Okay, so we have another example 3 here. And in example 3, we are expecting the following. 1, we are going to change the variable. Whenever you have a square root, better you let the one with the root be the one to be changed. I can call it another letter. Let me call it P. I don't want students or people out there to think that always the letter has to be U. Then that means 3x minus 1 is equal to P squared when you square on both what? On both sides. Now, if you are to differentiate, you will get 3 dx is going to be equal to 2p dp. It's from here that dx will be twice out of 3 of p dp. Furthermore, we have seen we have limits. We can change the limits as well. We had x, we now have p. X was 0, x was 1. So when x is 0, for example, take a look at this. I just chose this limit arbitrarily, but if we had not looked at it in this sense, you'll see that this will bring us problems. So the best thing to say is to maybe having integral from 1 up to 2. Let's change from 1 to 2, because 0 will bring a complex. Okay? And at this level, we might not be able to handle such solutions. So let's have a solution which is obvious, which is not a complex root. So we are integrating from x is 1 to x is 2. Now when x is 1, I can substitute here. Remember we said when x is 1, when you put here 1, you'll get 3 minus 2, minus 1, which will be, p will be root 2. Whereas when I put here 2, I'll get 6. 6 minus 1, I'll get 5. But under the root, so it's integral from root 2 to root what? 5. Now, when I come to substitute for p, I'll have integral from root 2 up to root 5 of what? X alone. X can be made the subject. X is p squared plus 1 divided by 3, because I make x the subject from right there. Then times dx, which is twice over 3 times p dp. When I open brackets, I'll have 1 over 9 integral. When the p enters into bracket, I'll have p cubed. The 2 has gone outside, plus p. This is what we are integrating from root 2 up to root 5. Because the p has penetrated to multiply the p squared into the bracket, the p multiplies the unity, which is 1, to give us a p. So when you integrate, you will have 2 out of 9 into brackets p power 4 out of 4 plus p to the square out of 2, and all this is integrable from root of 2 to root of 5. Remember we said it's okay if we do not put the constant, because we know after subtraction the constant will die out. So the answer will become 2 out of 9 into brackets. Root of 5 will give us 25 over 4. 5 over 2 minus root of 2 to the power of 4 is going to give us 4 over 4 plus 2 over 2. It is from this note that this one and that one give us a 1. This divided by that also give us a 1, realizing a 2. Whereas for this one, this is 2.5. 25 divided by 4. 25 divided by 4, the answer is what? The answer is 6.25. 6.25 plus 2.5, the answer is going to be 8.75. So, or if you want, you can add using fractions. For example, here the LCM is 4. You will have 25 plus 10. There is a minus 2 here. The minus 2 will give us a what? An 8. Or you press everything into a calculator and then you get the answer. So this is 35 minus 8. The answer is going to be 27 over 4 times 2 out of 9. By 9 once, by 9 thrice. By 2 once, by 2 twice. And the answer is going to be 1.5. So you can always confirm with the calculator and see. When you integrate this with the limits from 1 up to 2, do I get the answer as 1.5? If yes, then you're on the right track. So with this, you have changed the variable. 1, if it's a square root, you let the root be the unknown or the variable you're bringing on board. Then make x the subject so that you can substitute for x. Differentiate, get dx in terms of dp or p. Go to the bracket, to the table, and get new limits in terms of p. The limits of x were 1 and 2. Now the limits of p are root 2 and root 5. So integrate with respect from root 2 to root 5 with respect to p, and then you simplify. So that will be example 3, where we have to use such parameters when we are changing the variable. So allow me to share also example 4. If there is a number or a presentation that you're not comfortable with, you always just revisit a little, flashback, multiply it backwards, then you can review the presentation again. In that way, we'll be able to have whatever we need. Okay, there is an integral, and this integral is from pi by 6 to pi by 2 with cot of x out of the square root of cosec cubed of x dx. So we can let u be equal to cosec of x. So that u cubed is cosec cubed of x. So that du is equal to a negative cot x cosec x dx. It is from this note that you will see that du divided by cosec x is equal to a negative of cot x dx. Now this is the numerator. The whole of the numerator is going to be du out of cosec what? X. But cosec x is u, remember. So it will become, before I can go for what it becomes, I need to change the limits. X, we have u. X was pi by 6 up to pi by 2. This is 1 over sine of x. When I substitute pi by 6 is 30 degrees. So sine of 30 is a half. So 1 over half, the answer is 2. Whereas sine of what? Sine of pi by 2 is sine of 90. Sine of 90 is 1. Which will give us 1. Now, one may wonder, why are the limits coming from a smaller limit to a bigger limit to a smaller limit? You should not worry about it, because at one point there must be an induced negative, which is here. So this negative will cater for this arrangement of the limits. So it's from that note that I'll have the integral from 2 to 1 of a negative, yeah, of du over u, because this is the same as writing it as a negative du out of u times u cubed to the power a half, because this is cosec, which is u cubed becomes cosec cubed power half. So this will give us a negative 1 integral of 1 over u. This is 3 over 2 plus 1. 3 over 2 plus 1 gives us 5 over 2 du, from 2 up to 1. So when I integrate that, it's the same as u power negative 5 over 2 du, integrable from 2 up to 1, but it's a negative. So this is going to be, when you increase the power, you'll have a negative 5 over 2 plus 2, which is a negative 3 over 2. U power negative 3 over 2. There is a negative outside here, divided by a negative 3 over 2. The limits are from 2 up to 1. So it is from this note that the negative we have can be lost, and then you have 2 over 3, because the negative had now become a positive by division. 2 over 3 of u power negative 3 over 2 from 2 up to 1. When I substitute 1, I'll get 2 out of 3 minus, when I substitute 2, I'll have 2 out of 3 times 2 power negative 3 over 2. In actual sense, this is the same as 2 over 3. If you have a calc, you can do that very fast. Minus 2 out of, this is 3 times 2 times 8 power a half, which 8 power half is 2 root 2, and therefore this will give us 2 root 2 times 2 minus 2 divided by 3 times 2 root 2, and the answer will give me 6 root 2, and then the numerator will become what? 4 root 2 minus 2. I can divide everything by 2 so that I can simplify my expression very well, and in this sense, when I divide everything by 2, the answer will become 2 root 2 minus 1 divided by 3 of root 2. You can proceed and press the calc. That's how far I can go with my head. So even if you can proceed with the calculator, and then you can be able to get the solution. So with that, you're still using the method of what we call change of variable. And with that illustration, allow me to leave you with one number. Question 5 can be for the learners because of time. X root of 2x plus 3 with respect to dx from a half to 3. So you can proceed to Backhouse 2. If you have the old versions of Pure Mathematics by Backhouse 2, we have page 9. There is exercise 1C. You can take a look at that exercise. It has most of the questions that are talking about the change of variable. So today we have been looking at type 3 of integration. And allow me to stop here. My name is still Hamza Obama. And those of you out there who need assistance, it's holiday time, it's summer time. We are going in for summer, we're going in for holidays. So those of you who are interested in having some assistance, both in mathematics and in physics, you can always reach out to our numbers. Those who are in Uganda and you want to have Zoom lessons, Zoom coaching sessions, either physical or singular, whatever the case could be, please don't hesitate to dial the numbers or comment in the comment section. Whereas those ones who are in UK, English speaking countries, you have a student who is doing GSE exams very soon, who is studying the Cambridge curriculum, yeah, we can always help out both in physics and mathematics. My name is still Hamza Obama, and thank you for watching. Hope you've learned some integration under type 3, which is the change of variable. See you next time.